I'm Bill Geffro and working with the city of Bismarck for about 35 years. Let's see if, here we go. Oh, let's have a joke. I'll read it. What's for dinner? Nothing. That's what we had last night. I made enough for 2 nights. All right, not really funny. Clean joke? Okay. I would rather have questions that can't be answered than answers, well, that can't be questioned. So I'm in the lab. It's all about facts, all about data. It's all about being able to measure your success, which I'll hopefully talk about today. Oh, actually, you can actually read that a little bit, can't we? So, who works at a wastewater plant? Okay. Does your plant have odors? Who has odors at your plant? Okay. Which plants don't have odors? Are any of you nose dead? I'm not nose dead yet. I had COVID and lost it for about a half a day, then it come right back again. Can you guys go in your primary clarifiers? Yes. How many can? Okay, how many can't? Oh, okay, I can't. Been there 35 years and they ask me, why do you work here? I don't know, I'm trying to make things better. Assuming you can read this. Can you guys read this in the back of the room? Because I'm being cut short in my time again. So we're going to look at sulfides, hydrogen sulfides, where it starts, where it arises, a lot of times collection system. Bismarck has 22 forced mains, 3 private, work with those as well. And we'll look at the liquid stream options and the vapor phase options. In the water it's called liquid, and once it comes out from turbulence, it's called vapor. And that's where we get complaints from. And lots of corrosion. And we did lots of testing. I'm a lab rat on H2S. And we have a lot of case studies here to talk about. This is getting a little smaller. So we always want to know how wide is it, where it's at, what we can do about it, who owns it, what's the flow rates, what's the equipment. And then there's the most technical, is probably the most challenging. There's aesthetics involved with that, where you might place the devices that remove or capture the H2S. Where to place the equipment, can we do it outside, indoors, and the cost. The cost is always quite consideration. For example, when I first started working, anybody heard of potassium permanganate? And we were putting that stuff in left and right, and we could hardly see a difference. Well, it was quite expensive, but it wasn't very efficient, and so we probably could have never afforded to really do much with it. So it's all about what we can do. And then we added gas, chlorine gas. This is really cheap, 45 cents a pound, equivalent to 1 gallon of bleach. So sulfides, rotten egg odor, heavy in the air, once it's settled, it's toxic, corrosive. We built our new pretreatment building in 2008, and about 8 years later, we had $1 million worth of damage from the sulfides. They ate all the concrete, and then pretty started leaking through metal pipes. Well, this is really small. Okay, so hydrogen sulfide, some people are real sensitive like me, 0.5, 0.03, I've heard some people. Then you have all the other stuff that can come out in your sewer system. And then that once you start getting above 100 parts per million, you start having some serious issues, let alone 10-hour working environment, 8-hour working environment, 10, 20 for a short period of time. And yes, workers can be killed in the environment where they might be exposed to really high levels. Well, there's a lot of factors that affect the production of hydrogen sulfide. Might be kind of small, so I'll read them. The biggest one is detention time. How long does it sit in your force main? How often do you refresh your grease interceptors? And what's the temperature? In the winter, we can caustic wash a force main and have 2 or 3 months, or it'll stay way down. But in the summer, you get 10 days and it's coming right back up again. Your BOD, obviously, as everything becomes more efficient, your toilets use a gallon instead of 5 gallons, your wash machine uses 5 or 10 versus 40. We're using less water. Bismarck's wastewater is the same volume as it was 20 years ago. Yeah, we did a lot of I&I stuff and button-up plugs and cracks in manholes, and our flow keeps going down, but the engineers designed it for the flow to keep going up. And we'll put redundant force mains in, and it really got real messy. So our sulfide problem continues to get worse. BOD, pH, sulfates, we have plenty of sulfates in Missouri, sediment debris. And then the factors that influence H2S releases, of course, the main one is turbulence and pH. So, for example, here's a pH of 7. 50% is HS, 50% is H2S. Only the H2S comes out. So if you would shift your pH to 9, only 1% can be. So that's where the caustic helps to clean, or you could use other different chemicals with that. However, there's an equilibrium, and we'll talk about that more a little bit here. Here we go right here. S minus 2 is non-volatile, HS is volatile. We've tried a lot of chemicals. Calcium hydroxide, magnesium hydroxide, kind of the same. Okay, oh, this is really small. When the water runs out of oxygen, the bacteria will get oxygen from where? From where? Where does it get from? Sulfate. And then it converts it to H2S. And there's the bacteria, Thiobacillus deoxygans. It's just bacteria related. Once it comes out, it forms sulfuric acid from another bacteria. But it only happens when the pipe is not full. If the pipe is completely full, there's no release, there's no crown. If you have bad air releases, you'll get crown cutting in your force mains. And it'll eat up your concrete. Why? Because it forms sulfuric acid. What does sulfuric acid and concrete do? It turns your concrete to mush. Then it eats away your pipes. All right. So here's a picture overhead of the wastewater plant many years ago, but it's similar. Okay. Well, I talked about earlier when we have these redundant force mains. But they want to exercise them, the collection staff does. Oh, well, normally it's 3 to 5 or 7 or 10 even, but that's getting kind of high. However, when we flop those force mains over, the sulfides will get into the hundreds, dissolved. And you can take that times 10 or times 100, and that's what you get in the air. What this is a graph of is this is our H2S times 10. Okay? So when the H2S comes up, so does our effluent CBOD. And so does our ammonia. So that was a plant upset. So then we tried to do some things on that. We would crank the chemical up as far as we could. And we shush all the flow to equalization, where we had some aeration and some mixing going on. And then we would slowly pump that nasty thing. It goes on hacks in about maybe hour and a half, maybe 2 hours. So we wanted to get that slug from hitting our plant and cause an upset, in which we are working on that to this day. And then what is H2S called? It causes filamentous bacteria. Then you have the issues with settling in your clarifiers, final clarifiers. So the plant water comes in the headworks or pretreatment building, and then either equalization, we're going to add another 1.5 million, and then our clarifiers, and then to a trickle filter, we actually have a third one now. IFAS would probably have been the real thing to go to. And then our final clarifiers. And then we add chlorine, and we add SO2. And then we have the solids processing, anaerobic digestion, thickening. So where else does H2S come from in our system besides forest mains? We haven't done this in a while, but this is from our grease interceptors. We try to get out to the grease interceptors every year and inspect them. Are they pumping or not? Do they forget? Well, I have some averages and some maxes for the years. Here we have 88 parts dissolved H2S. And the pHs are really low too. Do you have pHs on this one here? No. They can get into 3s and 4s. And they can create a lot of odors. So what we don't want to do is over-design our interceptors. We want to right-size them, make them reasonable size. So we're going to have some pictures here. This is what happens with your concrete pipes. It eats it away, and pretty soon it comes out. This is what your metal, much like Adam talked about, low pHs from Coca-Cola. Not to pick and Coke, but did you know that pH of Coca-Cola is 3.2? And eventually, what happens when you have high pH concrete and low pH acids, you start to eat away. And, you know, it also affects your copper, electrical, structural integrity. It even attacks stainless steel. So here's kind of the first step of corrosion you're going to see. Your steps start getting corroded away. And then some more corrosion, and you can see the severity of corrosion. This is all from H2S. You can see the same thing for pH. And then further downstream, there's not even any steps left. Does pointer work? Nope. In fact, right there, that's what's left of a step. We actually had to go through here and replace all those manholes, which caused from a force main. Again, corrosion from H2S. Here it's starting to see rebar. Here's some more rebar from a different one. These have all been replaced too. All right, so how high does the H2S have to be before it eats all your concrete up? And this is life expectancy for a 3-inch diameter pipe, 1-inch cover. So again, the higher the H2S, you can get 5 years out of, and that's continuous. We try to keep H2S at least 5 average all the time, but we aren't quite doing that during the summer this year anyway. One of our first steps, besides the splitter box, we have these big barrel screens, self-cleaning barrel screens. I think they're maybe 6 foot in diameter, 12 foot long, can't remember. Brand new, that's what they look like. Self-cleaning pushes it out, solids come over, drop to the bottom. See, we have another picture. Oh yeah, here's what they look like, which pushes the solids forward. That's what happens when you get a lot of rags coming in. We do a lot of public education on rags too. Another presentation I could go on for a half hour or so. And what do rags do? They like to blind up your screens. And when you grind them up, they get small, and then they start latching on things. And then, what do the sulfides do? They're starting to eat away our stainless steel screens from coming in. And our grit chamber, this is all stainless steel. They had to be replaced. They last about 10 years. Normally we should have got 20, 25, or 30 out of it. So a slime layer can develop after 2 weeks in sewers and becomes permanent. There are 3 zones in the gelatinous slime layer: variable aerobic zone, anaerobic H2S zone, and inert anaerobic zone. That's where your fermentation occurs. And this whole thing, the slime layer, is probably as thick as your fingernail. So it happens in water lines. If you don't keep the water fresh and going, once you've established biofilm on water line, you ain't getting rid of it. However, in sewer lines, you can temporarily by pushing caustic in and getting a pH state of 12 or so and killing things off and degreasing. I don't know if you know about ORP, oxidation reduction potential. This is where you have oxygen. You can actually have a probe and measure it. Your anaerobic digesters, you're probably going to be down in here where you should be. This is what happens when you add nitrates. Calcium nitrate, sodium nitrate. Calcium's a liquid, that's a pretty common one. But when you add it, it keeps demanding more and more and more and more, and it gets really expensive. We've tried that a lot. Here's your sulfate and carbon. So this is a zone of your sulfide-producing anaerobic bacteria. There's another colorful one. This came from the minimization of odors and corrosion and collection systems, phase 1, water, environment, resource, foundation, 2007. It's like 300 some pages long. Some of these pictures came from that. Very informative if you ever want to work on getting some sulfides on your sewer system, collection system. H2S. So this is your pipe wall, anaerobic zone, sulfide producing zone, and laminar flow layer. And it's a cycle. And then let's keep going. So here's your H2S cycle. And as far as corrosion control or odor control, you can prevent it in those different stages. Here's your fancy bacteria. Alkalinity destruction, water, sulfuric acid comes back in. So it's called the sewer sulfide cycle. All right. Oh my God, this is small. Whew. HS2 is not volatile, does not contribute to odors. HS is bisulfide or hydrosulfide ion, can only exist in solution. And H2S, hydrogen sulfide, can exist as a gas dissolved in water, can leave water to exist as a free gas. The rate it leaves is governed by Henry's law, not Stokes' law, but and it's very dependent upon turbulence and pH. So wherever you have turbulence in your sewer system, that's where you get your H2S released. You can do a lot of things to help keeping it released. It's going to affect crowns of your pipes, your walls, surfaces above the water layer. Okay. Well, you can prevent the first pathway by using things that inhibit bacteria, anthraquinone, for example, or caustic slugs that we talked about earlier. You can grow back in 3 to 10 days, though. In the winter, it takes a lot longer because of temperature. Second pathway, we can use chemicals. We're fighting a liquid phase at that point. Oxygen injection, chemical addition like nitrates, iron salts, peroxide, potassium permanganate, chlorine, ferric chloride. Fargo uses ferrous chloride. Is that right, Mark? What do you guys do? You're calcium nitrate now? Yeah. We did a lot of experiments, different areas in our city, pilot testing at 5 different sites actually for that. Where you have a force main coming in to a gravity pipe, do you want it to drop and release, or maybe you want to come in below the surface of the water so you can push the bar farther so it doesn't come out in residential neighborhoods and manholes, and you get a lot of complaints from that. Oh, Oh yeah, you want to strip the H2S at the location you desire, where you can capture it. In our lift stations, we have two. We're going to go on a third one. We actually have scrubbers, where we have nutrients. There's two different layers, rocks, water comes down. You brought a lot of water, air through the biological scrubber and removes the sulfides. We have a huge one at the wastewater plant. Interrupting the third pathway, prevented sulfuric acid formation, surcharging, crown spraying, ventilation. This one doesn't work very well. Ventilation doesn't stop corrosion. Fourth pathway. If you have H2S and it's in a gravity line, you might want to think about using PVC, high density polyethylene, fiberglass, polypropylene, fiber reinforced plastics, coatings. The coatings have improved a lot. A lot of our coatings have just been ripped off and the concrete turned to mush. In our splitter box for our barrel screen, our splitter box for our primary clarifiers, we're still working on them right now, and we did some of this year as well. Epoxy resins work pretty well. Again, there's newer technology you might want to look into about what you do coat them with. Oh, like 20 minutes. I have to keep track of my time here. Have you ever noticed that a woman's, "I'll be ready in 5 minutes," and a man's, "I'll be home in 5 minutes," are exactly the same? Okay. Oh, here's a dead man walking. I don't know if you can see hers versus little tiny his. These are Mark Gungor jokes from Celebration Church, so they're clean jokes. All right. Similar to what we saw earlier, cast iron pipes or spun pipes. Again, the higher sulfides, the more degradation you're going to have. This is one of our lift stations. We have two force mains coming into it. Long detention time, higher sulfides. These pipes are 3 years old. And so we're continuously trying to fight that corrosion and protect our infrastructure. Very expensive to replace your infrastructure. This is our old pretreatment building. Again, pretty soon we started seeing water leaking out of our pipes. And we strapped on, we epoxied, and it just kept getting worse and worse. And whatever we did, we tried putting plugs on it, and pretty soon they were gone. You can see right here, the concrete is all gone on the top. And then pretty soon it started eating away. And then these pipes are only 8 years old. What do we have to do? Oh, rip them out. Keep them from leaking out the door and having SSOs from our pretreatment. And here comes the blue pipes. 30 inches, 24 inches. There's a little bit of metal holding them together some places. Here's a 1-year-old ductile iron pipe. It was supposed to be full of water. And it came out of our primary clarifier, and most of the sulfides are gone already. However, this pipe only ran half full, and it cut this groove right on top, and it's eaten away the concrete, and it's kind of like mashed potatoes. And then pretty soon it's going to eat a hole right through it. So this is another close to $1 million, half a million dollar project to either reline or replace. And we got a quote on it. It was pretty good, and he backed out and forgot that he forgot to add some money in it, and he wants to back out. But again, that's currently happening right now. What can you do? Nitrate salts. What's Fargo's doing right now? Minot, North Dakota is looking at that. Iron salts, we've tried those. We do have that at the treatment plant. They kind of precipitate it out. Nitrates give it oxygen. Oxidizers, many different types. Oxygen. That's what I'm in favor of. In about 2 years from now, we're going to get some oxygen generators right before the plant. We're going to pipe alongside it and inject oxygen into it, maybe 40, 50 milligrams per liter. So it ties the H2S up before it hits the plant. We know we won't be able to do all of it, but maybe 80, 90%, and at least try to protect our equipment more. You can mess with the pH. Remember how that pH, if you shift the pH, then you have the HS versus the H2S. Calcium hydroxide, we use mostly a lot of sodium hydroxide. And then here's the vapor phase, so that's a liquid phase vapor. Biofiltration, bioscrubber we talked about earlier. Carbon absorption, I wouldn't go with that one unless it's a really small volume of air. And then a wet scrubber. So this is what we do for caustic cleaning. We pop manhole covers up, upstream of force mains. Before it comes to the force main, well, here we'll probably dump 220 gallons of 50% sodium hydroxide. Picks the pH way up. It just knocks the crap out of the sulfides, and it degraces and it kills the bacteria, again, short term if it's in the summer. Liquid phase bioxide blend, Evoca does that. We've tried the AquaHawk from Hawkins Water Group. Again, it's calcium nitrate. This is proprietary, but it's the same thing. Peroxide, sometimes they work really well. I've heard Mandan, North Dakota. Mandan's here? Are you guys still using peroxide? Yep, and then what it does is, I got a call, and they said, well, we added this stuff, and it's just foaming everywhere, and it's just leaving this big streak, and it's, yeah, it's going to end up your lift station too, but you're cleaning it out. You're killing off the bacteria, you're degreasing it, and then you're going to have some effectiveness for a while. Nothing's forever. Oxygen, we talked about earlier, that's what I want to see. At the plant, chlorine, we've done that a lot. Ferric chloride, ferrous chloride, which Fargo used to add then, as far as I know. pH shifts, okay. This is where we add ferric chloride at the plant, stains everything. We have a couple, I don't know, what are they, maybe 10,000 gallon tanks or something. And here's sodium hydroxide for our odor control unit because the pH is about 0.5 to a 1 on a good day. This is what happens where you inject bleach into plant water pipe. So again, beware that wherever you add this chemical in a pipe that it wants to form corrosion. That was quite a few years, probably 15 or so. Oh, gotta check my time again. Okay. Therapist. My wife's a therapist. Your wife says you never buy her flowers. Is that true? Him. To be honest, I never knew she sold flowers. Come on, that's it. Okay. Clean jokes are hard to... Oop, here's another one. Okay. Them. How many push-ups can you do? Me. If they're the orange flavor, I know for a fact I can do 7 of them in one sitting. Yeah. Like Schwan Man's, that's pretty good. Orange push-ups. All right. So, nitrate salt summary. High degree of odor control, you get it down like to nothing, but it's a lot. Residual nitrate, easily tested. Capable of preventing 100% sulfides, moderate cost, non-hazardous. Basic formulations are available nationally. Some are blends are available only locally, regionally. So when you add oxygen, what's the end byproduct? Carbon dioxide and water. When you add nitrates, what's the end byproduct? Nitrogen gas. When the bacteria utilize sulfate, what's the byproduct? H2S, hydrogen sulfide. So the bugs prefer nitrate before this. So bugs prefer oxygen first, nitrate second, and sulfate last. And so then the bugs breed easier with nitrates. Call it easier to breathe, terminal electron acceptor. We won't get into chemistry. Oh, this is small. All right. Oxygen is probably the one that would work best for most facilities if you can make it work for you, if you can have a place to do it. If it's not too noisy in your neighborhood where the folks will hear this big instrument kick on and off. You can either add liquid and you have truck deliveries. So I went to WEFTEC about 3 years ago before COVID and had this special class and went to IHUS. And so to my mind, oxygen, and that's where we're going to go, versus air only 10 when it's colder. So you want to know what the demand is through that force main. We have 2 big force mains coming to our facility. How much consumption will it do? And you can jar test it and find that out, but it'd probably be lower in your jar test than in your actual force main. So oxygen can be added up to 40 milligrams per liter with no pressure and 120 to 300 milligrams per liter oxygen into your water under pressure. And the byproduct is no issue with the byproduct, CO2 and water. Seattle, Washington, again, some of this stuff, other cities were doing it at WEFTEC. Here's some of the ECO2 bubble system, blue and green and generic. I guess what I heard is that they're all good. It will remove the H2S, but it takes, we aren't sure for sure, but 5 to 20 minutes. So again, at a lift station would be the best, but at least 5 or 10 minutes before the water gets to the POTW. And you need 2 milligrams per liter oxygen per milligrams per liter H2S. So if you have 10 H2S, you're going to need at least 20 oxygen or more. So it's innovative, highly effective. Eco-friendly, alternate to traditional chemical treatments for water and wastewater. Again, the capital cost will be quite high. Get going, get started, versus just adding chemical. Water. Can water work? It sure can. If you got a 4-inch or 6-inch pipe, just 10 customers on it, when it's designed for 200 customers and it's brand new, what'll water do? There's oxygen in it, there's chlorine in it, and what does it do to the detention time in the force main? Reduces it. Higher retention time, the more generation of H2S. So if you can push water through it, we are doing that in 2 locations in Bismarck, Misty Waters, that new expensive development by the river, and then way north, Misty Waters. We're adding water, 30,000 gallons a day at one, 15,000 gallons a day at the other one. Takes about 90 minutes for bioxide. I think you can read it. I'm not going to read it to you if you can. Skipped one. Bioxide. Again, that shifts the pH up of what it does. You add it where chemical safety is concerned. Iron salts, ferric sulfate, ferrous sulfate, ferric chloride, ferrous chloride, they're different ones. Lesser degree of odor control, and it's really, really hard to get it lower than 0.5, and if you do that, it's going to consume a lot more. So typically about 1, and so if your plant can handle more than 1, or the H2S as 0.5 is going to cause you problems when you trickle filters, then you could struggle with this one, and that's why we struggle with this one. There's the magical formulas, how it works, and what you need. All right, so what we do in Bismarck, we have this new pretreatment building, which has severe corrosion in it already. We're trying to remove it, and everything is covered except for a couple areas, and those 2 areas I can't go into because this H2S comes out a little bit. But so we have 16,000 cubic feet per minute of air goes through. We capture it, and we humidify it first because it likes to have at least 96% to 98% humidity. And it goes into, we built this one here, a biofilter, so it goes underground there into this building. And they put all this fluorine down, and they put all this lava rock. It's proprietary, probably potassium permanganate with some, it's like kind of like lava rock, along with maybe some wood chips in it. And we filled it all up. And there's an irrigation system alongside to help wash it through. And it's worked pretty well for a while, until all the media collapsed and all of the coatings went to hell and started eating it up. So we had to recoat it with new coatings again. It probably lasted at least about 5 years, maybe 4 or 5 years. That's all the longer it lasted. So then they put high-density polyethylene, some cool-looking stuff, because HDPE is very corrosion resistant. So again, you have a choice where we have high sulfides, HDPE works really well. I also like that in interceptors too, high-density polyethylene interceptors. We'll talk about that in a minute. So a little zoom up, you can see how the air can flow. So it's a bottom flow up. It's between 2 and 4% sulfuric acid, what it generates from taking it from H2S and removing that. And the pH is about 0.5 to 1. So they replaced all the media again, put it back in. All right. So what's your action plan to reduce odors? You know, every force main is different. Every city is different. You have to look at every one as being unique. They aren't the same. Detention time is different. What chemical might be different here. We're going to get into some pilot test studies if I can move along faster. So collect your data, what are your options, do some bench testing, and then some pilot testing, and analyze your data, how well it works for you. Here's a really cheap, inefficient test by Hawk, H2S, methylene blue. We have a lot of these here, probably 12. We don't only have those, we have a lot of the gas techs nowadays for personal monitors. Oh, we're in a case study here. And the BioRem. Wow, this is really hard to read. This is peaks when they do force main switches. Up to 380, average of 29. It was designed to average 30. We're pushing it pretty hard. This is the building that it's in, right here. So, nope, that's a screw pump influent. I lied. Headworks is... This is where it's supposed to protect, because we don't want sulfides going high to our trickle filters or we'll wipe them out. I see it cut off the pretreatment building. Screw pump influent. It peaked out at, I don't know, let's see, where is it? 90, yep. And normally it's running 0. So when we flop our force mains over, then it hits our plant really high. And that's why we decided to equalize it and push it through really slow, so it doesn't cause a plant upset. Okay, so the force mains, we have a 30-inch and a 24 from Washington coming down to the treatment plant. And the detention time, about 3 hours is all it is. But if you have both on, it's 4.5 roughly. And then the other one, Wachter, is 2 hours and 2.9 hours. Again, we didn't used to have 2 force mains, but we wanted them to be redundant in case one broke. And we have had that happen, one leaked, and so we had to quickly repair it, the Wachter one. Flows, probably not that important. 12,600 feet, you start getting real long force mains, higher detention time. Another area south of here. I'm going to start going a little faster because I'm running out of time. Where are we at? Oh, okay. This is our plant upset data. You can see the ammonia is going good, all the time skyrocketed, and here we did some switching over. This is the BioRem. That's our influent again. See those huge peaks? So when we rotate the force mains, cause the issue. This is where we sample in our pretreatment building where it comes in. This is the barrel screen splitter blocks. That's the sampling manhole right there. And then pretreatment effluent, primary clarifier, splitter box. Different chemicals you could add. We talked about all these: oxygen, chlorine, bleach, peroxide, potassium permanganate, sodium, iron salts, calcium, magnesium. We have a private 3-mile force main, probably only about 10,000, maybe 20,000 tops. Collection staff called us and said, the door's rotting off. They tried to open the door and it kind of like fell apart and their vents are just gone. And so, well, let's find out where it's coming from. And then we did some dissolved air monitoring. No chemical addition. We saw some high H2S. This was way before we had the odor loggers. And then they started adding 4 gallons, knocked it to nothing. They added permanganate, went back up again. And then they started adding bleach again, 525. Normally your A-zone is about 12 and a half. So when they add about a gallon and a half, 2 gallons, keeps the sulfides down. Case study 2, Riverwood Drive, private. They thought that they have this lift station. Well, the odors won't come out so quickly. Instead of pumping it when it's 2 or 3 feet, and it pumps so often, we get odors all the time. Well, we'll just pump it when it's 15 feet. The clock starts when you start holding the water. And then it got really bad. And then we had an interceptor that was over-designed there too. This is, I think the cheapest house in there is probably $500,000 and up. So these were people that were pretty upset with odors. And I get it. I don't want to smell odors either next to my home. The city should take care of it. But this is private, so we had to work with the private. So it's not always as easy working with private. But they adjusted some stuff, and then right in here they had some grinder pumps. Where, do I have that? Yeah, grinder pumps. All right, so private homes, you 1 or 2 people maybe use, 50 gallons, 100 gallons a day. And they had these 500-gallon grinder injectors, pumps into the system. And the plumbers had them set really high so they wouldn't run so often, so the pumps would last longer. Again, clock starts ticking the longer you hold it, and it was huge sulfides. So anyway, what did we get? 708 parts per million for some peaks that were going on. And every time the pumps kicked on, it would go high again. So they lowered the set points in the pumps, both at that lift station and at the grinder pumps. There they are, grinder pumps right there, yep. Oh, Whispering Bay, right along the river. Here the lots only cost $250,000, so this is going to be a real high rise. But there's nobody on it yet, and so that's where we're adding the water in this one here. Pilot testing Southport Force Main. Some really high sulfides, 7-day averages, A-zone calcium nitrate. So Southport takes that water from that big facility. They had a 4-inch and they kind of greased it up and they went to a 6-inch. And we're still struggling with that one there. So we're adding water upstream of it. Another lift station pumps into that one. And we're adding about, I don't know how they told me, but they said roughly 32,000 gallons a day of water. And that's really knocked it down quite a bit. So it's helped out a lot. So you can see here the H2S is really low now. Oh, yeah, we had a bacteria salesman. We don't have one here, do we? Good. So we turned the water off, and they said the bacteria will work, and it kept going up and up and up, so we turned it off and went back to our water. In this case, it didn't work, but he said it was going to work great, and here's 1 week, 2 weeks, 3 weeks. We'll keep going, it's going to get better. No, it keeps getting worse. So we stopped using it. Again, it doesn't mean that it won't work in your situation somewhere else. See, I don't want to discredit some stuff, but remember I said is that each system, each force main, each area is going to have some uniqueness to it. Talked about that, increase pumping frequency, reduce the holding time, increase the water flow. Oh, at the airport, that was a stinky one too. That was actually those manholes that you saw that the steps just disappeared in concrete. And there's a grease interceptor there. We have a north one. See, it's how short it is. No issue. Maybe a half hour detention time, no problem. But this one here, got lots of problems. So in the airport, people live downstream. And initially, way back in 2005, we heard odor logger. We saw it dissolved of 6 parts coming in. Ticket times 10 to 100, and that's what's being released. And the sewer system's interconnected everywhere. All those gravity pipes, they're venting through your home, through the businesses' homes. It's an aeration system. So whatever happens somewhere, it goes somewhere else. And if you have a business, Their makeup gear is on the roof. And where's their sewer vent? On the roof. And you have a certain wind direction and it blows it right in. Oh, okay, the city's problem, right? I guess it is. So we try to solve it for them. And we did on this one here. What did we do? Well, that's what it was before. Actually, here's the odor logger data. Pumps kicks on, you get 90 parts per million, 10 parts average. Oh, and you can smell it 1,000 times lower. All right, here's some more stuff. What did we do? Now we got a 100-gallon one, but we started off with 2 and 4 and messed around and get complaints, and finally put her at 10 gallons a day and leave it there. It's about a 40,000 gallons per day force main. And what happened to it? Whew, look at that. Flatlined it. Then we maybe caustic washed it, and then we turned the chlorine on. And then, so now we down to about 7, but we don't dare go any lower. 7 gallons a day of 12.5% bleach guaranteed. They call it A-zone. It can be up to about 15, but again, it's $4 a gallon, but when we bid it'll be lower versus gas. Case study 5, Hay Creek, which goes to Wachter force main. Actually goes 26th Street force main, and then a Wachter force main, and it comes to the plant. We have 3 force mains in a row. Sometimes we even have 4. The more force mains you have in a row, the worse it gets, because it just keeps seeding, and it just goes back quickly. This problem, when I first started, we had the problem 35 years ago. It's still there, and it's going to outlive me and all the people that are there. Seriously. H2S, and we're going to build 3 more force mains too in our city. So again, you have to keep it down, or you're going to ruin your infrastructure. So this is what caustic soda does. We had a 275 there, and that was right in front of it. Washington lift. Kind of same thing, 50 gallons. That's coming from a force main upstream, but it's only like a 10-inch pipe. So we can get by with 50. So at some places we can get by 5 or 10, sometimes 50, sometimes 100, sometimes 275. Again, the larger the flow, the more you're going to have to add to it to get the pH way up. Washington lift station. All over the place. This is the 80 peak. And then, again, we added some bleach and I knocked it down. Washington, again, here's our bleach. But sometimes it comes right back up again for no expected reason. Other than our landfill gave us 275 gallons of ethylene glycol. Oh, really? When we talked about BOD, yeah. What's the BOD of ethylene glycol? Hundreds of thousands. Yep. I know you talked about earlier about a 0.5 or 0.6. That's good stuff, but bad stuff is about a 0.1. This glycol is right around 0.6. So it's that BOD to COD ratio. Again, here's a big food source, and it went up again. Iron, ferric chloride, testing to sulfide, see how it works. How do we get here? Historical information, investigation of original assumptions, jar testing, bench testing, and again, guess what? It costs money. You know, we budget a couple $100,000 a year for chemicals in our system, but that same amount at the plant. It's not cheap, otherwise, if you don't do it, it's going to ruin your infrastructure much quicker, and you're going to have to spend money on infrastructure repairs. Airstream odor removal options. Talked about a scrubber that we have. Again, here's the cost factors, advantages, the disadvantages, and let me check my clock. Am I getting out of time yet? Pretty quick. Biofilter, that's what we got. Medium frequency of use, low capital and operation maintenance cost, simple to use, VOC effective, media replacement, moisture monitoring. Works pretty good. Versus, say, what did Mandan have? Did they used to have a carbon scrubber before you went to biofilter? And it lasted for a while, but the VOCs eat up all the spaces and take up your media, and pretty soon your system has a continuous replacement requiring frequency And they ate it up so bad, we're out of the way last I heard. So you guys went more to a biofilter. So again, you have consulting engineers, help them work with you if you decide that you want to put something in it, where you want to put it in. You can bring it into activated sludge too, but again, you could have some release. Masking agents, we used to use a lot of those in our pretreatment building and make it kind of perfumey, and berry cherry was one of my favorite, but again, we got away from that. You got all this sulfites, let's cover it up, right? No, you still stink, sorta. Some people will recognize right through that. All right, so here's a biofilter. We actually pilot tested these before we decided to purchase a large one, another different style of one. These are for small amounts of air that escape the Purifil. A carbon probably will work for it, but again, if you have a serious issue with sulfides, and a lot of it, don't be going this route. But for some small things, small air amounts, then that's probably okay, because it's cheap. See, otherwise, the scrubbers, there's a lot of costs involved with that too. Oh, do y'all remember before the internet that people thought the cause of stupidity was a lack of access to information? Yeah, it wasn't that. You play dangerous sports? Yeah, I sometimes disagree with my wife. Oh, this is my last case example. These are 1,000-gallon interceptors. In 2005, we decided to follow EPA recommendations, at least before I was involved in sizing them. You get to put 5 1,000-gallon interceptors in. Today, I'd probably say, how about a GB 250? 250 gallon, 100 gallons per minute. That's high density made by Shire. Campos Endura makes them. There's a lot of other ones that make. I'm sure that we have a vendor here sells them like that too. But don't oversize them. The facility went out of business actually. So what we did do is said, that's too many. Let's just take 2 of them and put them in series. And it's still really high. Well, the Hampton Inn across the street was complaining about all odors. They have no restaurant, they have no interceptor, but they live close enough, and they're in a dead-end stream. Remember how the air wants to go wherever it wants to go once in a sewer system? Well, their parking lot is just awful sometimes. H2S is heavy, comes down, and okay, so just because somebody else has a problem or did it, somebody else gets to have the consequences of smell and odors, and customers aren't happy. So how high did it get here? 236 ppm. You think somebody could smell that? I'm thinking so. And the average is 8. And then they serviced the grease interceptor, and it kind of went away for a while. But we wanted to prove it. It's not coming upstream from some other force mains and somewhere else. Here's the Hampton Inn again. More H2S. And it happened in the evening. I wonder why that would happen. Why would it happen in the evening? Well, after a meal, right? And all the customers are served, huh? And you kick in the dishwasher. Well, here comes the flow, and that's the sulfides. No flow, it's okay, but also a lot of flow, here comes the sulfides. Well, I'm a man of science. I want to prove it. We'll show you. So what did we do? Here's so much of high sulfides, and we added 2 gallons of azone. Boop! Knocked it out. 15% chlorine. 1,000 gallon, actually there's 2 1,000, so, and then it came back, and then we added 2 more gallons. Poof! And so then it came back again. So then it proved to me that the Hampton Inn H2S was coming from across the street. There's now the stadium and the lodge, but they took that big restaurant and made it 2. And they got rid of the garbage disposal, but I'd like to see them rip them out or maybe put a 35 gallon per minute inside one. And for me, if you can capture the spray wash sink before the dishwasher, and if you have one, the wear wash sink, where you wash your greasy kettles, you're going to capture 90 to 95% of grease. Good! Whoo! That's how we got all of our old facilities that that were grandfathered in from doing something. And then guess what? They had to remove their garbage disposals. Because you can't be putting that into that 35 gallon per minute. Some are 50 and some are 20 below the spray wash sink. And like the presentation earlier that Adam said, put in a drop-in screen in your wire wash sink, actually your spray wash sink, and shush them into the garbage. We require screens in all drains in the facility. We also require all solids to be put in the trash, pretty much eliminating the usage of a garbage disposal. However, through the whole messy ordinance deal, we didn't put that in there. I would like to say no garbage disposals, food service establishments done. But you know what? New ones don't have them anyway. We did have one that wanted to put one in, and he said, okay, you can put a 1,000-gallon interceptor in. Oh my God, what a mistake. No, don't go there. Because it got so stinky, so heavily odored. So, well, why can't we do it now? Well, go ahead, get rid of the garbage disposal, put in a 100-gallon per minute one. Well, they're still working on it. Well, the point of this here is that don't oversize your interceptors, right-size them. Shoot for maybe a monthly servicing of the inside ones. If it's weekly, they probably won't do it. Shoot for 3 months on the outside. If it's every month, they probably won't do it. I know we have some on our weekend, like 5 weeks in a month, but again, it has to be some reasonableness of it. And if you have good BMPs in there, you'll have less grease to take out in the first place. And you have no garbage disposal and you screen everything you can, then you won't have all those solids on the bottom and you fall in that 25% rule. So to me, it's a common sense approach to right-size them, no garbage disposals, 25% rule. We don't monitor them. However, we work with our collection staff and we know where certain facilities stopped servicing them because grease starts showing up. So we went from 40 inadequate to 6 inadequate. And we're working on the other 6, and every year, like I said earlier, we will write them a letter at the end of the year. By the way, did you know that you're being surcharged $130 and it's going to go to $135 and then $140, just so you know. And here's what you need to do. And one of our hospitals said, well, we thought it was going to be $500,000. We couldn't afford to do that. They got a new manager come in, and they spent maybe $1,000 or $2,000. Poof, you're going to get your money back quickly in that. Dean had mentioned to that about the grease that they're seeing that they didn't know they have. Right size, reasonable approach. Treatment alternatives, state the alternative treatment strategies. So you need to have to know, what are your strategies? What are your chemicals? What do you want to add to that? What's going to work for you? And then you got to know what the costs are, and you have to budget for it. List your advantages and disadvantages, get approval, pilot test, and add your cost to your financial plan. Recommendations summarize the research results, recommend the strategies, identify action items, and after implementation, provide follow-up verification validation. Did it work? Oh. So H2S is going to create most of your odors in your sewer system, and your customers complain about. You can handle the vapor phase odors, and you can treat them. Again, we talked about this here. Each location is unique. You can do some dart testing to help you out. It's not perfect. Pilot testing will help you out more. And then test your waters, see how you're doing during the year. And never, ever tell your customers, we're going to take care of all the odors. It's going to be their odors. No, don't be putting your foot in your mouth. Say, well, maybe 80 or 90%. We'll do what we can, because you can't afford to treat all the odors all the time. Because there's nuances that goes up and down, things happen, you don't know what happened. So say we'll do the best we can, and we're hoping for 90. If you make a promise, you're going to regret that promise. We'll take care of all the odors with us here. Well, no, we'll take most of them. Questions? Do we have any questions? Yes, sir. What chemical do we use the most of?
One that's been the most effective for you.
Water at the small lift stations. Bleach at the little bit bigger ones, we have water and bleach. Ferric at the plant, but we want to go oxygen. And then those to me are probably the, however, if you have to get your sulfides down to nothing, then calcium nitrate would be. Again, you have to weigh the pros and cons of what you want. And then the bottom line is, what can you afford? There's not an unlimited budget. Any other questions? Yes, sir. How long did we run bioxide? Yeah. We didn't. No, we did calcium nitrate, which is the same thing. Because it's proprietary, and for us to use bioxide, we had to use their equipment. So we wanted to know, will it work, will it not work? We want to invest a bunch of money and have them put it in and have them all, and so it gets more complicated that just because it's proprietary, it's the same thing. So yeah, we did try it. In fact, we tried it at 3 different force mains, and we would add it, it would work good, and then it would consume more, and it consumed more, and we just couldn't keep up. We only have 200,000, and we're looking at 300, so then it just continues to grab more and more and more. And so you got a caustic wash in between. So that was our experience with bauxite. It does work. Yep.
Why does the slug loading of hydrogen sulfide result in like an ammonia upset for your guys' plants?
Say that again. What?
Why would a slug loading of the hydrogen sulfide result in like an ammonia upset at your guys' plant?
Okay. What was the sulfide concentration that caused the ammonia concentration increase? My understanding was, before dilution, that if you hit a trickle filter at 0.5 milligrams per liter for several hours, you'll cause plant upset to our trickle filter. Now, if you're recirculating, depending if you have 2 or 3 on, you might say, okay, you're goodbye for a 1. But we saw 2s, and they would stay there for several hours. And then all of a sudden our ammonia was 2s to 3s to 4s, and all of a sudden 25. And then our solids shoot out the roof 30 and higher, and then we're adding chemical and polymer to settle the solids out. Gets more expensive then, because now it's plant upset, and you go, oh, CBOD of 20, that's our limit. Oh, we got, this is the month of the year that we so struggle to meet our discharge permits. And that's the last thing we want to see is a non-compliance and have to call the state, oh, we violated our solids, and we violated our BOD. And then we contributed to the problem. We caused the problem internally. My boss didn't like to hear that at first. Again, show me the facts, show me the data, show me the information. It didn't take a day or 2 or a month or a year. It took years before we actually realized that. But now you could have some helpful hints of saying, what could it be? Always look internally first. The wet testing, well, that was nonylphenol oxalate, but we've had other issues. Most of them are internal. We thought it was other things, like styrene and lining of pipes when this happened at the same time. And well, no, we didn't have any styrene, sorry. No. All right.